integral of square root of sin x minus alpha divided by sin x plus alpha. We have to find the integral of square root of sin of x minus alpha divided by sin of x plus alpha. So first let's try to remove the square root from the numerator. So I'll multiply with sin x minus alpha, both numerator and denominator. So we'll write down, given what we need to find out is integral of square root of sin x minus alpha by sin of x plus alpha. Without integral, first let's try to simplify this. Once we are done, then we'll apply integral on top of it. So we'll multiply with sin of x minus alpha, both numerator and denominator. In the numerator, the square root will go away, so we'll have sin of x minus alpha. And in the denominator, we have sin of a plus b into sin of a minus b is sin square a minus sin square b, which is also equals to cos square b minus cos square a. So I'll put this in under root. Now let's try to get the integral back and try to expand the numerator. Sin of x minus alpha, trigonometric ratios of compound angles. So sin of a minus b is sin a cos b minus cos a sin b. So sin of x minus alpha is sin x cos alpha minus cos x sin alpha divided by square root of sin square x minus sin square alpha. Let us separate this into two parts and apply integral on each of them. So the first part will be sin x cos alpha divided by square root of sin square x minus sin square alpha minus cos x sin alpha divided by square root of sin square x minus sin square alpha. Now we want to work on substitution so that the numerator, whatever the sin x or cos x we have in the numerator, they have to be cancelled out. So how can we do that? If I want to have sin x as the derivative, which function I have to differentiate cos x? That means denominator I have to change it in terms of cos x. In the second integral, cos x we need to get in numerator. That means I can take sin x as another variable like t or u. I should be able to get it. So let us first try to change the denominator into cos for the first one, so that if I take cos x is t, then minus sin x dx will become dt. Sin square x minus sin square alpha can be written as cos square alpha minus cos square x, because we know sin square x is 1 minus cos square x and sin square alpha is 1 minus cos square alpha. Now once we are able to do that and separate them, for the first integral we will take cos x equals to t, and for the second integral we will take sin x equals to u. Now that will bring down the integral from complex to simple integral, for which we know the integral like standard form. Integral of 1 by root of a square minus x square, or integral 1 by root of x square minus a square, for which we already know what are the integrals. So let cos x equals to t and sin x equals to u. Then you have minus sin x dx is dt and cos x dx is du. So the first integral will become minus cos alpha dt divided by square root of t square cos square alpha minus t square. Let's write down integral of minus cos alpha dt divided by square root of cos square alpha minus t square minus cos x dx will go to du. So it will become integral of sine alpha d du divided by square root of u square minus sine square alpha. Now the first integral is of the form of integral of 1 by square root of a square minus x square, whereas the second one is of the form of integral of 1 by square root of x square minus a square. For both of this, we know the integral. Integral of 1 by square root of a square minus x square is sine inverse x by a. And integral of 1 by square root of x square minus a square is log of absolute value of x plus root of x square minus a square. Once we know that these are the integral formulas we can apply, we can directly go and substitute. So we can write down minus cos alpha will be out. Integral of dt by square root of cos square alpha minus t square will be sine inverse x by a. X is t, a is cos alpha, so t by cos alpha minus sine alpha. Integral of 1 by root of x square minus a square is log of x plus root of x square minus a square. Here x is u and a is sine alpha. So we'll have log of u plus square root of u square minus sine square alpha plus c. Now let's go back and do back substitution. T as cos x and u as sin x. The final step will be minus cos alpha into sine inverse cos x by cos alpha minus sine alpha into log of sin x plus square root of sin square x minus sin square alpha. Now certainly this integral can be solved in so many ways. This is one of the way which is easier once we try to remove the square root from the numerator and use trigonometric ratios of compound angles.